All right, so in this video, we are going to prove that the derivative of cosine x is equal to negative sine x. But how do we prove that this is true? Well, we can start out by using the definition of a derivative. So this is the definition of a derivative as a limit. And so what we're going to do is we are going to replace our function with cosine x. Essentially, we need to prove that the answer to this limit is equal to negative sine x. So then, how do we even start? Well, we sort of just have to play around with it. Notice that this is really just the cosine of something plus something. Well, if you recall, whenever you have the cosine of something plus something, well, that's the same thing as this. So if you recall, this is one of our identities from trigonometry. And so we're going to apply this to what we're doing right here. Right? So all I've done is I've re-expressed this as this, using our identity. So then, what do we do from here? Well, again, we got to keep playing around with it, but notice that these two terms both contain cosine of x. And therefore, we can group these two terms together and factor out cosine of x from them. So this is what you would get. And you could verify that if you were to distribute the cosine of x across, this is identical to what we have above. So then what can we do from here? Well, notice that in the numerator, we have the difference of two things. We have this minus this. So what we can do is we can split this fraction up into a difference of two fractions. And so this is what you would get. And again, you can verify that subtracting these two fractions is equivalent to the fraction above. And it's pretty easy because the denominators are the same, right? So you could verify that just in case it doesn't make sense. So yeah, going from here to here, that's what we did. So notice we are taking the limit of something minus something. Well, if you recall, there's this property of limits that says that whenever we have the limit of something minus something, we can re-express this as the limit of this minus the limit of this. So this is how we have rewritten it. Now, the next step that I'm about to perform may seem a little weird, but what we're going to do is we are going to take the cosine of x and take the sine of x, and we are going to pull them outside of their limits. But why are we allowed to do that? Because as h approaches 0, nothing happens to x. But why not? Because that comes from the definition of the derivative. Remember, as h approaches 0, right, you're letting just h approach 0, right? It's just h approaching 0. Nothing is happening to x. Therefore, cosine of x is treated as a constant as h approaches 0, because nothing happens to x. That's why we're allowed to pull these two things outside of the limit. And so that's our next step. So as you can see, all we have done is we have pulled out the cosine x and sine x from their limits. So at this point, it's just a matter of evaluating the results of these limits. And I've made videos on what the answers to these two limits are. And the answer to this limit is 0. The answer to this limit is 1. Therefore, we have cosine of x times 0 minus sine of x times 1. That results in negative sine x. So there it is. We have shown that the derivative of cosine x is negative sine x. And so this completes our proof, right? So yeah, this is pretty much it for this video.